Stars have always been described as distant fires, but in truth, they are more like ancient lullabies, resonant chords stretched across the silence of space. Their birth is not violent in the way human wars are violent, nor chaotic in the sense of earthly storms. Instead, it is a kind of slow music, a process so elongated across time that our entire civilizations rise and fall while a single star quietly awakens. Imagine vast clouds of hydrogen drifting through the galactic night like veils of vapor, invisible to human eyes but endless in their reach. These clouds, for millions of years, simply drift and gather, nudged together by the quiet insistence of gravity, as if some unseen hand were coaxing the first notes of a song. In the hush of the interstellar medium, where temperatures can plunge to near absolute zero, the atoms themselves move sluggishly, like dancers conserving their strength. And yet, when enough mass pools together, pressure mounts in their core. Slowly, softly, something begins to stir. Hydrogen atoms, the most basic building blocks of all matter, begin to fuse. And with that fusion, the first true light shines out. It does not roar, it does not scream. It glows steadily, persistently, whispering itself into the void. Every star we see has passed through this cradle of silence. From our own sun, a rather ordinary star, to the great blue giants that burn furiously for only a few million years, each one is a kind of musical phrase in the long composition of the cosmos. Astronomers describe these stellar births in the clinical language of density thresholds and nuclear ignition, but behind that language lies something that feels like poetry. For to watch stars form is to witness patience embodied. Our ancestors, looking up without instruments, must have felt the calm assurance of these lights. They seemed eternal, though we now know they are mortal. Still, their constancy against the night sky created the illusion of permanence, of rhythm. Stars became markers of the seasons, of harvest, of navigation across seas. They were guides, protectors, and symbols of what endures. But perhaps most of all, they lulled humanity into a sense of belonging, as if each glimmering point were a soft voice calling from the depths of time, "You are part of this vastness." Even today, in an age of telescopes that peer across billions of light years, the essence of that lullaby remains. When the Hubble Space Telescope captures the pillars of creation, those great towers of gas within the Eagle Nebula, we are not just seeing scientific data. We are witnessing a slow chord resonating across the universe, one note held for eons, soothing in its persistence. Stars do not hurry, they do not falter. They shine with a discipline that puts human restlessness to shame. For billions of years, they burn steadily, offering both warmth and structure, not just to planets that orbit them, but to the cosmos itself. They are the engines of chemical alchemy, forging carbon, oxygen, and iron, the elements of life within their hearts. And when they die, they scatter those gifts gently into the dark, seeding the universe with the possibility of new worlds, new oceans, and new beings who might one day look up in awe. To listen to the stars, then, is to listen to the universe's oldest song, a hymn composed not with instruments, but with hydrogen, gravity, and time. It is not a song of urgency, nor one of despair. It is calm, unwavering, like the steady breath of existence itself. For those who feel the weight of life pressing too heavily, the stars remind us of stillness, of patience, of rhythm that does not falter. They remind us that the universe, in its quietest places, is not chaotic but soothing, not hurried but serene. Hydrogen, the most unassuming element in the periodic table, is the quiet architect of the cosmos. It is not flamboyant, not heavy, not complex. It is simplicity incarnate. One proton, one electron, the most basic form of matter, and yet the seed from which all the stars, galaxies, and ultimately life itself would arise. It could almost be mistaken for nothing at all, and yet it is everything. For in the silence after the Big Bang, when the universe cooled from its initial burst of unimaginable heat, hydrogen was the first to settle. Picture it, a universe newborn, still glowing from its creation, gradually stretching and softening as the first particles coalesced. Out of the sea of subatomic chaos, hydrogen emerged like the first notes of a melody. Alongside helium and faint traces of lithium, it filled the cosmic void. But hydrogen was by far the most abundant. To this day, it remains so, composing nearly 3/4 of all baryonic matter. It is the cosmos's favorite building block, chosen over and over again by gravity to create the structures we admire in the night sky. When vast clouds of hydrogen drift together, they become the raw material for stars. Within their cores, under pressures and temperatures beyond earthly imagining, hydrogen atoms begin to fuse into helium, releasing energy in the process. This quiet reaction, nuclear fusion, is the heartbeat of the universe. Every gentle glow in the sky, every warmth that touches the earth from the sun, is powered by hydrogen surrendering itself. Each atom is like a tiny note being played, one after the other, forming the symphony of cosmic light. And yet, there is something deeply tranquil in the knowledge that hydrogen is patient. It does not rush into fusion. It lingers for billions of years, content to burn slowly. Our sun has been consuming hydrogen for 4.6 billion years already, and still it has another 5 billion years of this calm fuel remaining. Imagine a flame that burns not for moments, not for seasons, but for epochs, steady, unwavering, indifferent to the rise and fall of civilizations. Such is hydrogen's gift, a stability that stretches beyond imagination. Scientists studying hydrogen often describe it as mundane, but the truth is that its simplicity is its poetry. It does not need complexity to be meaningful. Hydrogen proves that even the most modest beginnings can build galaxies. It is the soft clay from which every planet, moon, and body of life was eventually sculpted. Without hydrogen, there would be no oxygen, no water, no carbon, the elements we think of as essential for life. For those heavier atoms were forged later, inside stars, as hydrogen quietly allowed itself to be transmuted into more intricate forms. Philosophically, hydrogen carries a soothing truth. From the simplest comes the grandest. From a single particle comes the architecture of reality itself. The universe, for all its incomprehensible size and age, was written in the language of hydrogen first. If one listens carefully, one can almost imagine hydrogen as the soft hum beneath the louder music of stars and galaxies, a background tone, simple yet eternal, upon which every other note is built. And there is something almost meditative about knowing that when you look at the stars, you are really seeing hydrogen's memory, its patience, its song. The warmth that touches your skin on a summer morning is a photon released from a hydrogen atom, freed after thousands of years of wandering through the sun's dense interior. It is as if the universe whispers directly through hydrogen's light, calm, enduring, infinite. In the vastness of time, civilizations will pass, stars will burn out, galaxies may even dissolve, but hydrogen will remain, drifting quietly in the cosmic seas, waiting for gravity to call upon it again. It will gather into new clouds, birth new stars, and repeat its patient song. There is serenity in this endless cycle, in the assurance that simplicity endures when all else fades. Hydrogen, the quietest of all elements, is also the most faithful. It is the cradle upon which the cosmos rests. It is the breath beneath creation's first stirrings. It is the universe's original lullaby. Gravity is often spoken of as a force, a pull, a weight pressing downward. But in the theatre of the cosmos, It is more like an embrace, silent, invisible, patient. It does not shout, nor does it strike. Instead, it waits, always persistent, always steady, gathering the wandering atoms of hydrogen, bending the paths of planets, curving the light of stars. Without gravity, there would be no galaxies, no suns, no worlds. There would be only dust, drifting forever apart. With it, there is structure, order, rhythm. Gravity is the universe's quiet hand, shaping the formless into form. Consider how galaxies hold their spirals together. Billions upon billions of stars, each a fire unto itself, do not scatter wildly into the void. They arc in harmony, tracing vast patterns across millions of light years. This balance exists because gravity keeps them bound, like dancers tethered by invisible threads, gliding across the floor of space-time. The Milky Way itself, our cosmic home, is one such dance. From afar, it appears as a soft swirl of light, yet within, gravity ensures that stars orbit gently, their motion part of a vast, choreographed embrace. Even in the smallest of scales, gravity whispers. On Earth, we feel it not as a thunderous command, but as the simple fact of weight, the steady tug that holds oceans to their basins and keeps our bodies rooted to the ground. But what we sense here is only a faint shadow of its true majesty. Out among the stars, gravity bends entire nebulae into wombs of creation. It squeezes matter until fusion ignites. It curves the very geometry of space-time so that even light, the swiftest traveler of all, cannot always escape its pull. Einstein revealed that gravity is not merely a force, but a bending of the fabric of reality itself. In his vision, space-time is like a vast, supple sheet, and objects of mass press upon it, curving it gently. Smaller bodies fall inward not because they are tugged, but because they are following the natural lines of this curvature. It is an idea both elegant and serene. Motion not as compulsion, but as flowing along the contours of reality. The planets do not fight against this. They drift easily, tracing arcs year after year, millennium after millennium, never tiring. To think of gravity in this way is to see the universe not as a place of violence, but of softness. Even black holes, those most extreme embodiments of gravity, can be seen as the ultimate embrace, so powerful that nothing, not even light, can leave. Though they are often imagined as terrifying, they can also be viewed as places of rest where matter and light fall inward and never need to leave again, enfolded into eternal stillness. Every orbit is a lullaby, the moon circling the Earth circling the sun drifting around the galaxy, all of it held together by gravity's patience. It is not in a hurry. Its timescale is longer than ours. Where we measure our lives in years and decades, gravity measures its artistry in millions and billions. That is why its embrace feels so calming. It reminds us of scales far beyond worry, far beyond the noise of daily life. Astronomers have noticed that galaxies move in ways that cannot be explained by the matter we can see. Stars at the edges orbit faster than they should, suggesting that gravity is working harder than visible matter allows. From this mystery emerged the idea of dark matter, an unseen mass woven into galaxies, amplifying gravity's embrace. Though we cannot see it, we feel its hand in the way stars remain bound together. Once again, gravity whispers of hidden depths, of truths beyond sight, and its calm persistence assures us that there is order even in the unknown. To lie beneath the night sky and gaze upward is to feel this embrace. The stars remain in their places, the constellations steady across centuries, not because of chance, but because of gravity's invisible bond. It is a reminder that in the vastness of chaos, there is also a structure, a tenderness that holds everything together. Gravity is not a prison, it is a promise. a promise that the universe does not drift into nothingness, but holds itself close, quiet, and eternal. Across the vast expanse of the universe, galaxies are not frozen in place. They drift, they turn, they stretch, and they merge. Yet their movements are not frantic. They are not sudden like storms. Instead, they are slow, steady, graceful like dancers in an endless ballet performed across the stage of space-time. Each galaxy, containing billions or even trillions of stars, glides through the dark with a patience that is almost unimaginable, their steps choreographed by the unseen hand of gravity. The Milky Way itself is not still. It rotates, taking its stars, including our Sun, on a journey around its center. One orbit requires about 225 million years. To us, such a span is inconceivable, but to the galaxy, it is just one turn of the wheel. Stars move in their gentle arcs, following invisible pathways that stretch for thousands of light years. From afar, this motion gives galaxies their spiraled or elliptical shapes, the curves forming slowly like brushstrokes on the canvas of the universe. Sometimes galaxies meet, but even collisions, in the cosmic sense, are not sudden impacts. They are encounters drawn out over billions of years. When the Milky Way and the Andromeda Galaxy eventually converge, their stars will not smash into one another. Instead, they will pass quietly through, like ghosts mingling. Gravity will weave their motions together, reshaping both into a single, larger form. What might seem destructive is in truth a merging, a slow and elegant blending of cosmic light. The distances involved ensure calmness. Galaxies are separated by millions of light years, and though they move swiftly relative to one another, the emptiness between them dilutes the sense of speed. If you could watch them from above, they would not seem to rush. They would seem to drift, unhurried, like clouds across a boundless sky. Their journeys are not measured in days or centuries, but in epochs so long that the rise and fall of species, even of planets themselves, is but a flicker within their motion. Telescopes have revealed this slow dance with astonishing clarity. Deep field images from Hubble show galaxies at every stage of movement, some solitary, some colliding, some stretched into long filaments by the tides of gravity. These shapes are not accidents, they are the signatures of motion written in light. Each arc, each spiral arm, each tail of stars extending into the void is part of this vast choreography. For humanity, there is something soothing in this perspective. Our lives, our histories, even our civilizations are tiny in comparison to the pace of galaxies. Where we measure time in years and decades, galaxies measure in billions. Their patience reminds us that urgency is an illusion of scale. The cosmos is not hurried. It is steady, deliberate, graceful. To lie beneath the night sky is to witness this dance from within, though our eyes cannot detect it. The constellations we know today will shift slowly over thousands of years as stars move along their paths, yet the change is too gradual for any single human to notice. This constancy, this stability of form, is why the ancients saw myth and story in the stars. But behind that stillness lies a grand, slow ballet, still unfolding. The slow dance of galaxies is not merely a scientific fact, it is a lesson in perspective. It tells us that creation does not always come with noise, that motion need not always be hurried. Sometimes the greatest transformations unfold quietly, stretched across aeons, like a dream that never ends. Light is often thought of as swift, instantaneous, unstoppable. To us, it seems to arrive the moment we flick a switch or look up at the night sky. But in truth, starlight is patient, so patient that the light we see tonight began its journey long before our species even existed. Every star above is not simply shining in the present, it is sending us a message from the past, a quiet story carried across unimaginable distances. The photons that touch your eyes on a clear evening may have begun their journey tens, hundreds, or thousands of years ago. From some of the farthest galaxies, the light has traveled for billions of years, carrying with it the image of the universe as it once was. When we look into deep space, we are looking not into distance alone, but into time itself. Light is our messenger, our only way of seeing across the abyss, and yet it does not rush. It does not hurry to reveal its secrets. It arrives steadily, after ages of drifting, like a river carving through eternity. Even within our own sun, light is delayed by the patience of matter. The photons born from fusion in its core do not travel straight outward. Instead, they scatter, bounce, and ricochet for thousands, sometimes millions of years before reaching the surface. Only then do they stream freely into space, traveling for 8 minutes before they find Earth. Every warm touch of sunlight on your skin, then, is a memory energy that was born deep within the sun in an age long before your lifetime. The sheer endurance of light is humbling. Consider a beam traveling across intergalactic voids, where nothing exists to scatter it. For billions of years it moves silently, never tiring, never fading, until it finally strikes the mirror of a telescope or the surface of a human eye. That single act, catching a photon, is a meeting across eternity. The human brain, with its fleeting perceptions, is briefly joined with the ancient persistence of the cosmos. Astronomers build entire careers from this patience. Every telescope, every detector, is nothing more than a device to catch these travelers. The faintest glow recorded on a CCD sensor may represent a galaxy so far away that its light began before the Earth itself formed. We live surrounded by these silent arrivals, the evidence of the universe's long memory. Philosophically, the journey of light offers comfort. It tells us that nothing is lost quickly, that the universe preserves its history in beams and glows, in the soft persistence of photons crossing the night. Even when stars die, their light continues onward, still moving through the dark, still carrying the memory of what once was. When one lies beneath the stars, this truth becomes deeply soothing. You are not simply gazing upward, you are reaching backward. You are touching the past, resting your eyes on the slow patience of light that has traveled farther than any human will ever go. The universe, in this way, is generous. It does not withhold its story. It simply requires patience, calmness, and the quiet willingness to look. Light's million-year journey is not a race. It is a lullaby stretched across time, a song that does not end quickly but drifts endlessly toward those who will one day notice it. And in that awareness, in that calm patience of the cosmos, we too can rest. Among the most serene sights in the heavens are the nebulae, those vast, cloud-like structures that float across the galaxy, appearing to us as soft veils of color, suspended in silence. They are not solid. They are not turbulent in the way earthly storms are turbulent. They are diffuse, ghostly, light years across, and yet so delicate that a single breath would disperse them if one could stand within their folds. To human eyes through a telescope, they resemble dreamscapes, clouds painted in hues of rose, emerald, violet, and sapphire, each a portrait of creation written on the canvas of the cosmos. But nebulae are not simply beautiful. They are the universe's cradles. Within these vast clouds of hydrogen and dust, stars are born. Gravity gathers the diffuse gas into denser knots, and within these knots, heat rises until fusion awakens. Every shining star, every glowing sun began its life inside a nebula, wrapped in the stillness of cosmic mist. The Orion Nebula, visible as a faint patch beneath Orion's belt, is one such nursery. It is a place where stars are forming even now, a living cradle, quietly at work while we watch from across light years of distance. The colors we see in nebulae are not painted by hand but by physics. Ultraviolet light from young stars excites the gas, causing it to glow in radiant shades. Hydrogen produces reds, oxygen greens, helium blues. The effect is a cosmic watercolor, slow in its brushstrokes, never rushed, unfolding over millions of years. A single nebula may stretch across dozens of light years, yet it drifts silently, almost imperceptibly changing as stars bloom within it and then drift away. There are different kinds of nebulae, each carrying its own quiet story. Emission nebulae glow because of the energy of newborn stars. Reflection nebulae shine faintly as they scatter starlight, appearing blue like the Earth's sky. Dark nebulae, perhaps the most mysterious of all, do not glow at all. They blot out the background stars like shadows draped across the galaxy. Yet within their darkness, creation stirs, waiting. Even supernova remnants like the Crab Nebula, born from the death of a massive star, hold a strange serenity, for even in their ghostly aftermath, they shimmer with quiet, expanding filaments, proof that endings can also be beginnings. The pillars of creation, immortalized in Hubble's image of the Eagle Nebula, may be the most famous of these cosmic clouds. Rising like colossal towers, they stretch for light years, yet appear as fragile as smoke. Within their dusty columns, stars are gestating, hidden from our view, waiting for their light to pierce the darkness. To contemplate such structures is to feel both awe and calmness. They are immense, beyond comprehension, yet they exude softness, like celestial clouds floating in the still night of the galaxy. And though nebulae inspire wonder, they are also reminders of time's patience. For the processes they contain unfold not in minutes or hours, but in millennia and aeons. A star may take millions of years to emerge from its nebula womb. Civilizations could rise and fall, languages invented and forgotten, while a single knot of gas slowly gathers enough weight to ignite. It is a rhythm of creation so slow, so patient, that it becomes soothing to contemplate. Philosophically, nebulae suggest something gentle about the universe's nature, for though the cosmos contains violence, supernovae, black holes, collisions, it also holds these cradles of softness. It shows us that creation too can be tender, that birth does not always come in fire and fury. Sometimes it begins in silence, in clouds that drift like dreams, shaping futures we cannot yet see. To rest one's gaze on a nebula is to peer into the universe's nursery. It is to see the place where stars begin their songs, wrapped first in quiet mist before they blaze into brilliance. And in that vision lies calmness, reassurance, that even in the vast dark, beauty gathers patiently, waiting for its moment to shine. Long before there were stars, before galaxies had gathered themselves into spirals and clusters, there was a faint echo, the lingering whisper of the universe's birth. Today, we call it the cosmic microwave background, the afterglow of the Big Bang, a nearly uniform radiation that fills all of space. It is not visible to our eyes, but it is everywhere, surrounding us like a soft and invisible lullaby that has been playing for 13.8 billion years. This radiation was first released when the universe was young, only about 380,000 years old. At that time, matter and energy were so entangled that light could not travel freely. The universe was an opaque fog of particles, a storm where photons were constantly scattered. But as the cosmos expanded and cooled, the fog thinned. Electrons and protons joined into atoms, and suddenly light was free to flow. That moment is imprinted forever as the cosmic microwave background, an ocean of faint radiation that has drifted through space ever since, softening with expansion, stretching into longer wavelengths until it reached the microwave spectrum we detect today. In 1965, two engineers, Arno Penzias and Robert Wilson stumbled upon this whisper. Working with a large antenna in New Jersey, they heard a persistent noise that no adjustment could remove. It was not interference from Earth, nor from the galaxy. It was everywhere, constant, uniform. They had discovered the universe's first afterglow, though at the time they only knew it as an unexplained hiss. What seemed like static was, in truth, the soft murmur of creation itself. Today, satellites like COBE, WMAP and Planck have mapped this radiation with extraordinary detail. To the human eye, it is uniform, but in reality, it carries faint ripples, tiny fluctuations in temperature and density. These ripples were the seeds from which galaxies and stars would eventually form. In their subtlety lies the entire structure of the cosmos. A fraction of a degree warmer here, a fraction cooler there, and billions of years later those small differences became clusters of galaxies, threads of the cosmic web, and the starlit night we know. There is something deeply calming about the cosmic background. It is uniform across the sky, like a blanket of warmth stretched in every direction. It does not shout, it hums. Its frequency is gentle, its tone low, its presence eternal. Every point in space carries this same background, reminding us that we are still bathed in the afterglow of the universe's earliest dawn. Scientists speak of it as evidence, a proof of the Big Bang, a treasure map of cosmology, but one can also see it as something more poetic, the universe's first memory, still singing softly to itself. To know that even in the darkest void, there is this gentle radiation, is to know that the cosmos is never truly silent. For humanity, it is also a reassurance. The cosmic microwave background tells us that there is continuity, that the present is linked to the past by an unbroken thread of light. It tells us that we are connected not just to stars, not just to galaxies, but to the very first fire of existence. And though that fire has cooled, it has not vanished. It drifts quietly, endlessly, a reminder of beginnings. If one could listen to the universe itself, to its quiet breathing, it would sound like this, the soft, ancient whisper of the cosmic background, the lullaby of time, carrying forward across eternity. Among the calmest yet most paradoxical presences in the universe are black holes. They are not luminous, not radiant, not even visible by ordinary sight. They do not blaze or thunder. Instead, they are silent horizons, places where gravity has drawn space and time inward so completely that not even light can escape. To the human imagination, they might seem terrifying, yet in truth, there is a strange serenity to them. They are stillness, embodied motion without sound, collapse without end. A black hole begins not in silence, but in the fiery death of a massive star. When fusion can no longer support the star's weight, its core collapses inward under its own gravity. The outer layers may explode in a supernova, scattering elements across the galaxy, but deep at the center, the collapse continues. The matter condenses into a point so dense, so compact, that ordinary physics breaks down. The boundary that forms around it is the event horizon, the threshold beyond which nothing returns. To us, it is the ultimate hush, a one-way passage into darkness. And yet, black holes are not emptiness. They are presence. They bend the fabric of space-time, curving it so sharply that the paths of stars and even entire gas clouds are altered by their invisible embrace. Astronomers have observed stars orbiting around something unseen at the heart of our galaxy, Sagittarius A*, moving at incredible speeds. Their motions reveal the quiet hand of a black hole, 4 million times the mass of our Sun, anchoring the Milky Way. Though it cannot be seen directly, its still gravity holds the galaxy's core together like the weight at the center of a spinning wheel. Black holes do not roar. They do not demand attention. They simply exist, quietly reshaping reality. Matter that falls inward spirals across their event horizons, heating to brilliance before vanishing. Some black holes emit jets of particles that stretch for thousands of light years, not in chaos, but in elegant streams, narrow and precise. These jets, too, are part of their calm paradox. Silence at the center, streams of light at the edges. Einstein's relativity describes their horizons as boundaries in space-time itself, places where time slows infinitely. To an outside observer, anything falling toward a black hole appears to freeze, suspended forever at the edge. To the object itself, time passes as normal, and it slips silently across the boundary. In this duality lies a haunting calmness. Black holes remind us that time is not absolute, that the universe itself holds mysteries beyond human comprehension. Stephen Hawking added another layer to this paradox by suggesting that black holes are not eternal prisons. Through quantum effects near the event horizon, they may radiate faint energy now known as Hawking radiation. If true, it means that over incomprehensible spans of time, black holes themselves will evaporate, vanishing back into the quiet from which they came. Even these dark giants, so seemingly permanent, are temporary whispers in the long drift of the cosmos. Philosophically, a black hole can be seen not as destruction but as rest. It is the place where matter ceases to struggle, where light itself comes to a halt. In their stillness, black holes represent the ultimate silence, the quiet end of motion. They are not noise, but pause eternal, unbroken, calming in their inevitability. To imagine them is not to imagine violence but surrender, and in that surrender, perhaps, there is peace, a reminder that the universe, for all its brilliance and fire, also holds spaces of absolute quiet, where time itself seems to stop. Einstein's theory of relativity reshaped the way humanity sees the cosmos. It told us that space and time are not separate entities, but a single fabric, pliable and continuous, bending under the weight of matter and energy. To picture it is to imagine an invisible sheet stretched infinitely in all directions, supple and smooth, upon which every star, every planet, every galaxy rests. It is not rigid, it yields softly, curving around mass, guiding motion not through force but through form. This fabric spacetime is not something we see with our eyes. We only witness its effects. The orbit of the Earth around the Sun, for instance, is not a constant tug-of-war between mass and force, as Newton once described. It is instead the Earth gliding along a curve etched into spacetime itself. The Sun presses into the fabric, and the Earth follows that curve, tracing its yearly arc with perfect patience. The planets, the moons, even the comets drifting through their long elliptical paths, all of them are dancers moving to the contours of this unseen sheet. Light, too, follows spacetime's curves. When it passes near a star or galaxy, its path bends, not because of a push or a pull, but because the very stage upon which it travels is curved. This bending of light is called gravitational lensing, and it has allowed us to glimpse galaxies otherwise hidden. Through this effect, space-time itself becomes a lens, a quiet magnifying glass held up to the distant universe. Einstein's insight was not just scientific, it was deeply poetic. To say that reality itself bends, that time slows in the presence of gravity, that the very ticking of clocks is relative to where one stands, this is not only a shift in physics but a reimagining of existence. Time, so often thought of as absolute, becomes pliable. Space, once thought of as empty, becomes alive. The cosmos itself becomes a fabric that breathes and curves with mass and motion. Astronomers have tested these ideas again and again. The orbit of Mercury, slightly irregular under Newton's laws, falls perfectly into place under Einstein's equations. The bending of starlight observed during an eclipse in 1919 confirmed relativity to the world. And even now, detectors like LIGO listen to ripples in space-time itself, gravitational waves, born from the collisions of black holes billions of light-years away. These waves stretch and compress the fabric as they pass through us, so faint we cannot feel them, yet so real that delicate instruments can detect their subtle rhythms. There is comfort in this vision of the universe, for if space and time are fabric, then nothing is truly isolated. Every star bends the sheet around it, every planet tugs gently at its surroundings, every being contributes, however faintly, to the curvature of existence. We are woven into the same cloth, part of the same structure, part of the same soft fabric that cradles galaxies. Philosophically, the idea of space-time as fabric is profoundly calming. It tells us that the universe is not chaos but order, not disconnected fragments but a continuous whole, and while we cannot see it, we move within it, supported by its invisible embrace. To live is to ride the currents of this fabric, to drift along its soft curves, carried forward not by force but by form. In Einstein's space-time, the universe is not rigid but supple, not mechanical but graceful. It is a reminder that the cosmos itself is not harsh but yielding, not brittle but fluid. Reality is not a prison of straight lines, but a soft, bending sheet upon which existence flows with infinite patience. Stephen Hawking spent his life staring into the quiet abyss of black holes, and what he found there was not silence alone, but paradox. He asked questions no one else dared to ask. Do black holes truly erase everything that falls into them? Does the universe permit such finality? His reflections revealed a universe at once mysterious and delicate, where the edges of reality hold contradictions that still unsettle physics. In the 1970 seconds, Hawking proposed that black holes are not entirely black. According to quantum theory, pairs of particles constantly flicker into existence and vanish in the vacuum of space. Near the event horizon, one of these particles may fall inward while the other escapes, carrying with it a faint trace of energy. To an outside observer, this appears as radiation streaming away from the black hole itself. Hawking radiation. For the first time, black holes were not eternal traps. They could evaporate, losing mass over unimaginable spans of time until they vanished entirely. This suggestion was quiet in tone but seismic in implication. For if black holes radiate, then the universe has a way of softening even its most absolute edges. Nothing, not even these silent horizons, lasts forever. Over trillions upon trillions of years, they too would fade, leaving behind only empty space, like a whisper dissolving into silence. But Hawking's paradox ran deeper. In classical physics, anything that crosses the horizon of a black hole is lost forever, its information destroyed. Yet quantum mechanics insists that information cannot be destroyed, it must persist, in some form, always. These two principles collided at the edge of black holes, leaving physics in a quiet state of contradiction. Does information vanish into nothingness? Or is it somehow preserved, woven subtly into the faint glow of Hawking radiation? For decades, physicists have debated this paradox. Some suggest that black holes encode information on their horizons, like holograms etched into the surface of space-time. Others argue that information leaks out slowly in the radiation itself, though so scrambled it would be unrecognizable. Still others propose that our very understanding of space and time must evolve, that black holes are keys to a deeper, more unified theory of the universe. In all these ideas, the paradox endures a mystery, a soft tension at the boundary between relativity and quantum physics. And yet, there is something calming in Hawking's vision. His radiation implies that nothing in the universe is truly eternal, not even the darkest giants. Everything changes, everything drifts, everything fades softly with time. The cosmos is not static but dynamic, an ongoing process of transformation. Even destruction is not finality, but transition. Black holes, once thought to be ultimate prisons, become part of a cycle, a patient dissolving into silence, a return to the background hum of the universe. Philosophically, Hawking's paradox invites reflection. If even black holes, those most extreme regions of reality, are not beyond the laws of balance, then perhaps the universe itself is woven from consistency, from order, from the quiet assurance that nothing is wasted. Information, memory, matter, all of it must persist in some form, even if hidden from view. Nothing is lost absolutely. In contemplating Hawking's paradoxes, we glimpse not only the edges of science, but also a deep serenity. For the cosmos, in its vastness, does not rush to reveal its secrets. It offers hints, paradoxes, contradictions, quiet puzzles for us to ponder, knowing full well that answers may come only after centuries of thought. And in this patience, this willingness to hold mystery, the universe teaches us something about our own restless search for meaning. Hawking's quiet paradoxes remain unresolved, but perhaps that is their gift, a reminder that the unknown need not frighten us. It can soothe us, inviting us to rest in the vast mystery, to find comfort in the fact that even the greatest minds could not solve it all. Some questions remain as soft horizons, stretching endlessly ahead. The universe is not still. From the moment of its birth, it has been expanding, space itself stretching like fabric pulled taut. Galaxies are not drifting apart through motion alone. Rather, the very stage on which they exist is widening. Imagine dots drawn on the surface of a balloon when the balloon inflates. The dots move farther from one another, not because they are traveling, but because the surface beneath them is stretching. So it is with the cosmos. In the 1920 seconds, Edwin Hubble observed that distant galaxies were redshifted, their light stretched toward longer wavelengths. This meant they were receding, and not randomly, but in proportion to their distance. The farther away a galaxy lay, the faster it was moving outward. The discovery was astonishing. It told us that the universe itself is not static, not eternal in its present form, but dynamic, ever-changing. Space is not a backdrop, it is alive with expansion. At first, this expansion was imagined as gentle, a steady unfolding of cosmic fabric. Yet later measurements revealed something more profound. The rate of expansion is accelerating. Galaxies are not merely drifting, they are sliding apart ever faster, as though propelled by some unseen hand. This revelation, made in the late 1990 seconds through studies of distant supernovae, shook cosmology. It implied the existence of a force or an energy pushing outward, stronger than the pull of gravity. Today we call it dark energy, though its nature remains one of science's deepest mysteries. To picture the expansion is not to picture chaos. It is not violent. On human scales, it is imperceptible. The atoms of your body do not expand. The solar system remains bound. Even galaxies remain intact, held together by gravity. The expansion lives only in the immense distances between clusters, where the void itself grows. From our vantage point, it is serene. Galaxies quietly receding, the night sky ever so slowly thinning, stretched over billions of years. There is comfort in this slowness. Though the universe is expanding, the change unfolds so gradually that even across countless generations, the stars above will remain familiar. Only on timescales of billions of years will the night sky truly shift, as galaxies fade beyond the reach of light. To us, the expansion is a background process, steady and silent, like the slow rising of a tide. Philosophically, the expansion reminds us that change is natural and that even the vastest structures are not fixed. The cosmos breathes outward, and in that breath we find rhythm. Galaxies part not in anger, but in calmness, making room for silence, making room for stillness. When we gaze at the stars, we are seeing not only light, but motion light stretched by the expansion itself, a subtle signature that space is alive. Each photon carries with it the mark of this slow drift, this gentle widening of existence. And though it is mysterious, it is also reassuring. The universe does not collapse inward upon itself. It stretches outward, steadily, quietly, like a river that flows not toward an end, but into an ever-widening sea. If the expansion of the universe is a gentle tide, then dark energy is the quiet wind urging that tide forward. It is unseen, unfelt, and yet it shapes the destiny of everything. Discovered not through direct observation, but through its influence, dark energy is the name we give to the unknown force, driving galaxies apart at an accelerating pace. It does not roar, it does not announce itself. It works silently, invisibly, patiently, changing the fate of the cosmos with a whisper rather than a shout. In the late 1990 seconds, teams of astronomers studying distant Type Ia supernovae noticed something astonishing. These stellar explosions, used as cosmic mile markers, appeared dimmer than expected, as though farther away than they should be. The conclusion was shocking. The expansion of the universe was not slowing down under gravity's embrace, but speeding up, as though some hidden hand were pushing everything outward. The term dark energy was born a label for the unknown. And yet, what is it? Scientists still cannot say. Perhaps it is a property of space itself, a cosmological constant, as Einstein once imagined and then abandoned, a quiet energy woven into the vacuum. Perhaps it is a dynamic field, changing with time, fluctuating like a subtle heartbeat of reality. Or perhaps it is something else entirely, beyond our grasp, an echo of deeper laws not yet written. What we know is this: dark energy accounts for nearly 70% of the universe, yet it remains invisible, intangible, a mystery resting at the heart of existence. Despite its magnitude, dark energy is tranquil. It does not disrupt galaxies or solar systems. It does not tear planets from their suns. On local scales, gravity rules, and life proceeds undisturbed. Dark energy works only across the largest distances, gently pushing galaxies farther apart, shaping the cosmic horizon. Its influence is profound yet patient, a force felt only across billions of light years and billions of years. There is something soothing in this vast patience. For while dark energy ensures that the cosmos will one day be silent, galaxies receding beyond each other's sight, stars burning out, the night sky growing emptier, it does so without haste. The process will take trillions of years, a timescale beyond all human anxiety. It is a slow drift, a quiet fading, a transformation that reminds us of the impermanence of all things, but does not threaten the present. Philosophically, dark energy is like a soft paradox. It is the greatest part of the universe, yet we cannot see it. It is everywhere, yet it leaves us untouched. It is powerful, yet it works so gently that we only notice it in the careful plotting of galaxies. It is the cosmos reminding us that the unseen can be the most influential, that absence can carry as much weight as presence, that mystery can cradle reality itself. To contemplate dark energy is to imagine the universe as a great ocean, with galaxies as islands slowly drifting apart, carried on currents we cannot feel. There is no violence in this motion, only inevitability. The universe exhales, and in that exhalation lies both mystery and calm. Beneath the vastness of galaxies and the sweep of cosmic expansion lies a world so small it is invisible, and yet it governs everything. This is the world of quantum fields, subtle, invisible frameworks that fill all of space, vibrating gently, their fluctuations shaping the matter and forces of the universe. To the untrained eye, space may appear empty, a void between stars, but physics tells us it is never truly empty. Instead, it is alive with constant activity, with fluctuations so delicate they can scarcely be imagined, like the faintest ripples upon an unseen sea. Every particle is born from a field. The electron, the photon, the quark, each is not an isolated entity, but an excitation, a ripple in a deeper fabric. Just as a note arises from the vibration of a string, particles arise from the trembling of quantum fields. Even when no particle is present, the fields remain, humming softly with vacuum energy, their fluctuations flickering in and out of existence. The universe, at its deepest level, is never silent. It hums quietly, constantly, with this quantum song. This constant fluctuation may sound chaotic, but in truth it is serene. These fields have endured since the birth of the cosmos, woven into its foundation, stable yet restless, invisible yet universal. They explain why particles exist, why forces act, why matter gathers. Without them, there would be no atoms, no stars, no galaxies, no life. Every calm star in the sky is built upon this microscopic whispering. The discovery of the Higgs field is one of the most profound examples of this hidden order. Long theorized, it was finally confirmed in 2012 with the detection of the Higgs boson at CERN's Large Hadron Collider. This field, invisible but omnipresent, is what gives particles their mass. Without it, the universe would remain a haze of weightless particles, never coalescing into stars or planets. The Higgs field is like an unseen atmosphere, enveloping every particle, giving them substance. It is a gentle embrace, universal, unending, silent, yet vital. Quantum fields also connect us to one of the great cosmic mysteries, dark energy. Some theories suggest that the vacuum fluctuations of these fields contribute to the expansion of the universe, pushing galaxies apart. If so, then the quiet hum of quantum fields is not just the foundation of matter, but also the driver of cosmic destiny. The tiniest whispers become the grandest symphony, the smallest fluctuations steering the course of everything. There is an almost meditative quality to this realization. What we perceive as stillness is, in truth, ceaseless activity. The void is not void at all, but filled with delicate trembling, a cosmic breath so fine it escapes perception. And yet, from this trembling comes stability. From this quiet chaos comes order. Philosophically, the presence of quantum fields reminds us that reality is layered. What appears calm may be alive with hidden depth. What seems silent may be filled with unspoken music. The universe is not only what we see with our eyes, it is also what lies beneath, what hums invisibly, what sustains existence without recognition. To rest in the thought of quantum fields is to rest in the assurance that even the smallest fluctuations matter, that the universe is stitched together by invisible vibrations, patient and eternal. It is to imagine the cosmos not as an empty void, but as a quiet ocean of unseen waves, upon which all things float, gently, endlessly. Stretching across the universe is a structure so immense, so delicate, that only with the most powerful telescopes have we begun to glimpse its true form. It is called the cosmic web, a vast network of filaments composed of galaxies, clusters, and dark matter, weaving together into a structure that spans billions of light years. To see it in maps and simulations is to see the universe not as random scatter, but as a tapestry, a net of glowing threads suspended in infinite darkness. These filaments are not dense like walls or chains. They are airy bridges, strings of galaxies flowing across the void. Between them lie immense, silent regions, cosmic voids, expanses almost entirely empty, where galaxies are scarce and silence dominates. Together, filaments and voids create the largest pattern ever known, a structure that resembles both a spider's web and the delicate branching of neurons in a brain. It is as if the universe itself has grown along invisible veins, distributing galaxies like drops of dew across an immeasurable net. This web was not woven overnight. It grew from the faint ripples in the cosmic microwave background, those subtle variations in density present when the universe was only a few 100,000 years old. Over billions of years, gravity amplified those ripples, pulling matter together into threads while leaving other regions empty. The result is a structure that is both immense and fragile, a pattern that emerges only when one steps back far enough to see beyond individual galaxies. To contemplate the cosmic web is to recognize scale in its most humbling form. Each filament may stretch hundreds of millions of light years, yet within it, galaxies drift quietly, stars burn, and planets orbit tiny jewels on a thread of incomprehensible length. Humanity, in this vast embroidery, is smaller than a mote of dust, yet still part of the pattern. The realization brings not fear, but serenity. Even in smallness, we belong. Simulations such as the Millennium Run or Illustris project have allowed scientists to recreate this web in exquisite detail. They show galaxies sliding along filaments, merging in nodes where the threads intersect, much like rivers flowing into lakes. These nodes become galaxy clusters, brilliant knots of light in the grand net, while the filaments feed them with streams of matter. The entire cosmos, then, behaves like a living system, filaments like veins, clusters like organs, voids like lungs, breathing in silence. There is a quiet beauty in this vision. The universe is not chaos but geometry, not noise but order. Its largest structure resembles the most delicate of designs, as if written by an unseen hand. And yet it was not written by design at all, but by the patient workings of gravity, dark matter, and time. In that patience lies reassurance. Beauty does not require haste. Complexity does not demand noise. Philosophically, the cosmic web reminds us of interconnection. Every galaxy, every star, every planet is part of a larger whole, strung together by threads we cannot see but that are undeniably real. Just as the neurons of the brain give rise to consciousness through their network, so too might the universe express itself through this cosmic net, though what it expresses is left to wonder. To rest one's thoughts upon the cosmic web is to feel part of a grand pattern, woven not just across space, but across time. It is to know that even the emptiest voids are framed by structure, that silence itself is bordered by threads of light. The web is not just science, it is a poem written in galaxies, a net that cradles the stars, a reminder that everything, no matter how distant, is connected. Amid the immensity of galaxies and the stillness of voids, there is another rhythm at work, one quieter, more intimate, yet equally eternal. It is the rhythm of moons, circling their planets in ceaseless harmony. They are cosmic companions, tethered by gravity, moving in arcs so precise that their dance becomes a metronome for the passage of time. Where galaxies spiral and expand, moons revolve, their motions repeating, 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 like the steady beat of a heart in the dark. The moon, our own familiar companion, has been circling Earth for more than 4 billion years. Its face, cratered and silent, drifts across the sky in cycles that govern tides, calendars, and myths. Its orbit is not chaotic. It is steady, so steady that it has inspired humanity's earliest sense of rhythm. The waxing and waning of its light, the predictability of its path, became a natural clock long before mechanical ones were built. Even now, in a world of electronic timekeeping, the moon still offers its ancient measure, whispering the patience of celestial motion. But the Moon is not alone in its gentle orbit. Across the solar system, countless moons turn with quiet persistence. Jupiter's four largest Io, Europa, Ganymede, and Callisto move in a resonance so precise that their gravitational pulls synchronize, locking their orbits together in harmony. Every time Ganymede completes one orbit, Europa completes two, and Io completes four, a celestial symphony unfolding in silence. Saturn, adorned with more than 80 moons, hosts Titan, with its hazy atmosphere and methane seas, and Enceladus, whose icy plumes spray upward like fountains in the void. Each moves calmly, drawn along curves carved by gravity, never straying, never faltering. The harmony of moons is not hurried. Their revolutions span days, weeks, and months, unfolding slowly, gently. Some drift so far from their planets that their orbits take years to complete. Yet all are steady, all are patient. Their cycles bring stability to the chaos of space, their rhythm a lullaby written into the fabric of planetary systems. Even their interactions tell a story of balance. Tidal forces between moons and planets slow rotations, shift orbits, and create warmth beneath icy crusts. Europa's hidden ocean, perhaps capable of harboring life, is stirred by the gravitational tug of Jupiter and its siblings. Enceladus's geysers are powered by similar tides, turning silent revolutions into sources of energy. In these quiet exchanges, moons transform emptiness into possibility, gravity into heat, silence into motion. Philosophically, the moons remind us of companionship. No planet is truly alone. Each carries a retinue of smaller worlds, faithful attendants that revolve endlessly, their devotion marked in arcs across time. Even Earth, which might seem solitary among the stars, has its moon, always near, always watching, always reflecting light into the night. In their harmony, moons embody loyalty and patience, the assurance that even in the vast silence, there are partners in the dance. To imagine the orbits of moons is to imagine a celestial music box, with each revolution a note, each resonance a chord, repeating without end. Their harmony is soft, eternal, unhurried. It is the cosmos keeping time, reminding us that in a universe of change, there are also patterns that endure, steady as breath, gentle as sleep. Beyond the solid ground of planets and the frozen stone of moons, there is something softer still, the atmospheres that wrap them. Thin, invisible veils of gas, held in place by gravity, breathing gently across planetary surfaces. Each atmosphere is a kind of skin, fragile yet protective, moving in patterns that are calm when seen from afar. Winds shift, clouds drift, pressure ebbs and flows. To look at an atmosphere from space is to see a planet breathing, slowly, steadily, like a sleeper at rest. On Earth, this breathing is familiar. The swirl of white clouds across blue oceans, the gentle currents of air carrying warmth from one hemisphere to another. Our atmosphere is a living blanket, both delicate and enduring. Its gases are in constant motion, stirred by sunlight, cooled by night. Yet when viewed from orbit, these restless movements appear serene. The storms and tempests that trouble us are, on the scale of the planet, faint brushstrokes in a vast painting. Earth inhales carbon dioxide, exhales oxygen, circulates nitrogen, and through this rhythm sustains the entire web of life. Other worlds breathe differently. Mars carries a thin atmosphere of carbon dioxide, barely able to hold warmth, where winds carve dust into soft dunes and global storms rise slowly, drifting across its rust-colored deserts. Venus wears a thick shroud of clouds, its atmosphere dense and heavy, pressing with a weight 90 times that of Earth's. Yet from above, the planet's pale yellow veil glows like a lantern, soft and uniform. Even the gas giants, Jupiter and Saturn, are atmospheres in themselves, colossal oceans of hydrogen and helium swirling endlessly. From afar, their bands of clouds seem like brushstrokes of calm, striped ribbons turning patiently around their spheres. Among the moons, too, there are breaths. Titan, Saturn's largest moon, wears a dense haze of nitrogen and methane, a miniature world with rivers and seas of liquid hydrocarbons, its weather cycling in echoes of Earth's but in alien slowness. Pluto, at the edge of the Sun's influence, has a tenuous atmosphere that freezes and falls back to the surface during its long winter, then rises again when sunlight returns. Even here, in the silence of the outer reaches, atmospheres move in rhythm, breathing quietly with the pace of orbits. To contemplate atmospheres is to contemplate fragility. They are thin Earths, if scaled to a globe, would be no thicker than the skin of an apple. Yet they are resilient, enduring across ages, sheltering surfaces, softening starlight, scattering rays into dawns and sunsets. They make skies blue, clouds white, horizons red. They bring color and tone to the silence of space. Philosophically, atmospheres are reminders of gentleness. They are veils that protect without being solid, strength expressed through softness. They teach us that protection does not always require walls or stone. Sometimes it is enough to wrap the world in a quiet breath. Seen from afar, planets with atmospheres glow differently from those without. Their halos shimmer faintly against the darkness, like lanterns suspended in the void. To look upon them is to see not violence, but calmness, a world at rest, wrapped in its own sigh, drifting in the cosmic night. Among all the adornments of the solar system, few are as quietly mesmerizing as Saturn's rings. They shimmer like frozen music, vast, delicate arcs of ice and dust, suspended in harmony around the planet. To see them through a telescope is to glimpse a perfection that feels almost impossible, thin, flat, luminous, like grooves etched into the night by a careful hand. They are not solid, though they appear so. They are billions of tiny fragments, some no larger than grains of sand, others the size of mountains moving together, orbiting in unison as if playing notes in a celestial symphony. The rings stretch wide, tens of thousands of kilometers across, yet they are astonishingly thin, sometimes no thicker than a few hundred meters. If scaled down to the size of a sheet of paper, they would be thinner than a single hair. And yet, from Earth, they shine like a perfect band of light, an illusion of solidity created by countless small particles reflecting the sun's glow. Their brilliance is a chorus of tiny voices, each fragment silent on its own, together forming a dazzling harmony. How they formed remains a mystery. Some scientists suggest the rings are remnants of a moon shattered long ago, torn apart by Saturn's immense gravity. Others think they are primordial, leftovers from the birth of the planet itself. Regardless of their origin, they endure as one of the most serene sights in the solar system, a reminder that beauty can emerge from both creation and destruction. The dynamics of the rings are not chaotic but rhythmic. Shepherd moons orbit near their edges, sculpting sharp boundaries, guiding streams of ice into precise arcs. Resonances with larger moons carve gaps and patterns, creating divisions like the Cassini division, a broad band that seems empty but is simply less crowded. The whole system is alive with motion, yet perfectly balanced, like strings vibrating in tune. Viewed up close by spacecraft like Cassini, the rings reveal endless complexity. Waves ripple across them where moons tug at their particles. Spokes of charged dust rise and fade like fleeting shadows. Yet even these subtle movements are slow, patient, graceful. Nothing hurries. Nothing disrupts the quiet. To contemplate Saturn's rings is to hear music in silence. Their arcs suggest notes held for billions of years, tones so low and steady that only the universe itself could perceive them. They embody symmetry, patience and rhythm, as if Saturn were playing a chord that never fades. Philosophically, they remind us that fragility and beauty can coexist. The rings are transient on cosmic scales eventually. They may fall inward, raining ice upon Saturn, but for now they endure, glowing softly against the darkness, a masterpiece of impermanence. Their very existence is proof that the universe does not only build for permanence, it also builds for wonder, fleeting but exquisite. To gaze at them is to find rest. The rings do not speak of urgency. They whisper of patience, of harmony, of music played in frozen light. They are, in truth, the cosmos itself pausing to hum. Time is often imagined as a swift current, rushing us from moment to moment, dragging us forward whether we are ready or not. Yet on the scale of the cosmos, time flows more like a wide, unhurried river. It bends, meanders, slows, and stretches, its surface smooth, its motion patient. For the universe, there is no haste. Stars burn for billions of years. Galaxies drift for eons. Even black holes, thought of as eternal, evaporate only after spans of time so long they defy imagination. Against such scales, the ticking of human clocks is like the flutter of a moth's wings against an ancient stone. This sense of slowness is built into the fabric of the cosmos. Time does not move uniformly everywhere. According to relativity, it slows in the presence of gravity, bends under the influence of motion. A clock on the surface of Earth ticks more slowly than one in orbit. A clock near a black hole ticks more slowly than one far away. Time is not rigid but fluid, flowing at different rates depending on where one stands. And yet, to each observer, it feels steady, calm, unbroken. Consider a star. Its birth unfolds over millions of years as hydrogen gathers, compresses, and finally ignites. Its life, burning steadily, may last for billions. Even its death, whether in the quiet fading of a red dwarf or the brilliant finale of a supernova, is but one moment in an existence spanning longer than life itself on Earth. To a star, time is not quick. It is vast, slow, and tranquil. The river of time also reminds us of perspective. Humanity, in its brief span, has existed for only a breath of cosmic history. If the universe's life were compressed into a single year, our entire story would occupy only the final seconds of December 31. And yet, we feel ourselves at the center of history, racing against the clock. The cosmos tells us otherwise. The river flows endlessly, whether we rush or not. There is serenity in this, for while time may carry all things forward, it does so gently. The river does not break suddenly. It glides, patient, smooth. Its currents shape galaxies, its eddies birth stars, its flow erodes even the strongest structures, but always slowly, always calmly. Philosophically, the river of time is both humbling and soothing. It tells us that our urgency is not the universe's urgency, that our anxieties are brief ripples against an eternal current. It invites us to rest in the knowledge that the river will continue, that we are carried upon it like leaves drifting across its surface, part of a flow larger and older than we can grasp. To imagine time in this way is to soften its sting. It is no longer a tyrant, counting down moments, but a quiet river, carrying us forward with inevitability and calm. And if one listens carefully, one can almost hear it, the slow lapping of the cosmic current, steady, eternal, flowing into infinity. Relativity, that great insight of Einstein, tells us that time is not fixed, that it bends and distorts under the influence of motion and gravity. These distortions are not violent. They are gentle, subtle shifts like ripples spreading across a pond, changing the reflections ever so slightly. Time, which we once believed to be a universal heartbeat ticking steadily everywhere, is instead elastic. It slows near massive bodies. It stretches when objects move swiftly. It is a fabric that bends softly under weight, a rhythm that changes with the dance of matter and motion. Imagine two clocks, one resting on Earth's surface, another lifted into orbit above. The one on Earth, deeper in the planet's gravitational embrace, ticks slightly slower than the one in space. The difference is imperceptible in daily life, but real, so real that satellites must account for it in order for GPS to function. Without relativity's corrections, navigation systems would falter within days. The universe itself keeps time not with absolute uniformity but with relativity's gentle adjustments. Now imagine a clock placed near the event horizon of a black hole. To an observer far away, its ticking slows almost to stillness. Seconds stretch into hours, into years, until the clock appears frozen, hovering forever at the edge. Yet to the clock itself, time flows normally, steadily, as it always has. Two truths coexist. One calm, local, ordinary. The other distorted, slowed, almost halted. Time, under relativity, becomes not a single river, but many streams, flowing differently depending on where one stands. Even velocity bends time. An astronaut traveling at speeds close to light would experience time more slowly than those left behind. Upon returning, she would find that years, decades, perhaps centuries had passed on Earth, while for her, only a short journey had unfolded. This is not fantasy but law, written into the fabric of space-time itself. The faster we move, the slower time caresses us. And yet, these distortions are not disruptive. They do not fracture reality into chaos. They are consistent, predictable, soft. They remind us that time is not a rigid cage, but a supple thread, stretching and bending with circumstance. The cosmos, in this vision, is not mechanical, but flexible, alive with variation. Philosophically, relativity's distortions offer solace. They tell us that time is not absolute, that the ticking we hear is not universal law but local rhythm. We are not imprisoned by one clock, one measure, but part of a flexible fabric that flows differently in every corner of the universe. Time is not harsh, it is pliant, not fixed, but gentle. Even when imagining the extremes, black holes, near light speeds, cosmic horizons, the distortions of relativity evoke awe rather than fear. They tell us that reality itself is elastic, that what we think of as rigid boundaries are, in truth, soft and curved. To rest in this knowledge is to find calmness. For if even time can bend, then perhaps our anxieties too can soften. Relativity teaches us to see the universe not as a prison of rigid laws, but as a symphony of gentle distortions, each note played differently depending on where it is heard. And in that symphony lies a harmony that is vast, serene, eternal. Beyond the boundaries of our visible cosmos lies a possibility so vast and soothing, it feels like a dream, the multiverse. The idea is not fantasy alone, but an extension of physics, born from equations and theories that whisper of worlds beyond our own. If true, it means our universe may be only one bubble in an endless ocean of bubbles, each expanding, each unique, each carrying its own stars, laws, and stories. The concept arises from cosmic inflation, the rapid expansion of space in the earliest fraction of a second after the Big Bang. If inflation happened once, it may still be happening, endlessly, in other regions beyond our sight. Space could be producing universe after universe, a vast froth of realities blooming like foam upon an infinite sea. Our cosmos, with its galaxies and stars, could be only one blossom in a field without edges. In some visions, these universes may follow the same physical rules as ours, filled with familiar galaxies and stars. In others, the constants may shift, gravity stronger or weaker, light behaving differently, matter arranging itself in ways we cannot imagine. Some universes might flare briefly and fade, others might expand forever. In this vast multiverse, the variations are endless. Each universe a dreamscape spun from possibility. For us, there is calm in such speculation. If there are infinite universes, then the strangeness of our own, its balance, its beauty, its laws, need not be unique. It is part of a larger pattern, one expression among countless others. The accidents of physics that allow stars and life may not be accidents at all, but inevitabilities, given endless chances to unfold. Our existence, then, is not fragile, not solitary, but part of a cosmic chorus where every note, every universe, plays in harmony. The multiverse also offers perspective on mystery. In our cosmos, questions remain unanswered. What is dark energy? Why do physical constants have the values they do? Why does the universe exist at all? In the multiverse, these may not require singular answers. They may simply be one configuration among countless possibilities, no more strange than a tree with many branches, each branch different, each branch natural. Philosophically, the multiverse is comforting. It suggests that reality is not a single story but an infinite library, with universes as its volumes. Each page tells a different tale, each written in the same quiet ink of physics, each unfolding without haste. If our universe is one dream, the multiverse is an endless succession of dreams, layered upon one another, drifting forever. To close one's eyes and imagine this is to imagine a cosmos without edges, without finality, without solitude. Even if our own universe should fade into darkness, the larger sea endures, birthing new worlds, new stars, new lights. In that vision lies serenity, the assurance that the story never ends, that reality itself is infinite, soft, and eternal. Before galaxies spun their spirals, before stars lit their fires, the universe was dark, silent, waiting. Then, in an instant smaller than imagination can hold, it took its first breath. This moment is called cosmic inflation, a sudden, inconceivably rapid expansion of space itself. In less than a heartbeat, the universe grew from smaller than an atom to larger than a galaxy, stretching smooth, flat, and vast, like a lung filling after a long silence. What drove this first breath remains uncertain. Physicists propose that a peculiar field, the inflaton, filled the young cosmos with energy, pushing space outward at speeds beyond comprehension. The expansion did not carry galaxies apart. For none yet existed, it created the very fabric they would someday inhabit. In that breath, the seeds of everything were planted, the ripples in density that would become galaxies, the uniform glow that would become the cosmic background, the conditions that would allow stars, planets, and eventually life. Unlike an explosion, inflation was quiet. There was no sound, for there was no air. There was only expansion, calm, immense, unstoppable. Its silence is what makes it so powerful. It was not noise that shaped the universe, but the whisper of space-time itself unfolding. Evidence of this first breath lingers still. The cosmic microwave background carries imprints of the tiny fluctuations birthed during inflation, faint ripples spread across the sky. These ripples became the scaffolding of the cosmic web, the gentle irregularities around which matter gathered. What began as the softest tremors became the grand structures of the cosmos. Inflation also hints at possibilities beyond our universe. If the field responsible for it still lingers, still bubbles and flickers in the deep fabric of reality, then perhaps inflation never truly ended. Perhaps it continues elsewhere, birthing other universes beyond our horizon, each with its own stars, its own laws, its own silence. Philosophically, inflation is both unsettling and calming. It suggests that everything we know emerged from stillness, from a single breath that expanded into all existence. It tells us that creation does not require thunder. It can begin in silence, in a whisper, in the softest motion of space itself. To imagine this first breath is to imagine the most delicate of awakenings, a slumbering cosmos opening its eyes, not with violence, but with calm inevitability. The universe, from its very beginning, was a patient unfolding, a slow exhalation into eternity. Between the luminous arcs of galaxies, between the threads of the cosmic web, there are vast expanses of nothing. These regions are called cosmic voids, immense stretches of near emptiness, some hundreds of millions of light years across, where only a few lonely galaxies drift. To look at a map of the universe is to see filaments and clusters outlining the edges of these voids, like a net of light surrounding pools of silence. The voids themselves are not chaos, but stillness, the most tranquil regions in existence. In these great hollows, matter is scarce. The density is so low that one could travel for tens of millions of light years without encountering a galaxy. No bustling clusters, no crowded intersections of stars, only vast darkness, broken occasionally by a faint glimmer. These places are quieter than any silence we know on Earth. They are emptiness stretched across unimaginable distances, like calm oceans in which no waves stir. Astronomers have identified many such voids, with the Boötes void among the most famous. Discovered in 1981, it is nearly 330 million light-years across, containing far fewer galaxies than expected for such an expanse. Within its boundaries, the night would appear darker, lonelier, emptier, and yet there is serenity in that emptiness. The void is not destruction. It is space at rest, unhurried, unfilled. These regions tell us something profound about the universe, that its beauty is not only in what is present, but also in what is absent. The cosmic web's bright filaments are defined by the darkness surrounding them. The voids give contrast, allowing structure to exist. Without emptiness, there would be no form, no balance, no pattern. The physics of voids is subtle. Though empty of galaxies, they are not truly empty. Wisps of hydrogen drift there, faint streams of dark matter thread through, and even the cosmic microwave background passes gently through them, stretched a little more by their vast expanses. They are not chaos but simplicity regions where gravity has pulled matter away toward the edges, leaving behind a purity of stillness. To imagine a void is to imagine being adrift in a sea of silence. There is no noise, no movement, no hurry. Light itself passes more slowly into emptiness, fading, stretching into longer wavelengths. In such places, time feels unbroken, endless, as though the universe itself has paused to breathe. Philosophically, the voids remind us that absence has its own form of presence. They are the pauses between notes, the silence that gives music shape. They are proof that stillness is not the lack of creation, but part of its design. In their calm darkness, the voids whisper that the universe is not crowded chaos, but balanced emptiness, that rest is as essential as motion. For us, there is comfort in knowing such places exist. While galaxies blaze and stars explode, the voids remain unchanging, silent, serene. They are the universe's quiet retreats, oceans of calmness stretching forever, reminders that even in infinity, there are places of perfect rest. Amid the stillness of the voids and the grandeur of galaxies, there are wanderers comets, icy travelers that trace long arcs across the solar system. They are fragile bodies of ice, rock, and dust, remnants from the dawn of planetary formation, preserved in cold storage at the edges of the sun's domain. When disturbed, they fall inward, moving with quiet persistence, their journeys spanning millions of years. They are the drifters, the voyagers, the slow messengers of the outer dark. A comet's path is an ellipse, elongated and patient. Some return within decades, others only after thousands of years. Halley's Comet, perhaps the most famous, revisits Earth every 76 years, a rhythm so steady that it has been recorded since antiquity. Its glow in the night sky inspired awe, myth, and fear, but behind the spectacle lies serenity. Its orbit is precise, its return inevitable. Like the steady breath of the cosmos, comets move with patience, their rhythms unfolding beyond human lifetimes. When comets approach the sun, they awaken. Heat causes their frozen surfaces to sublimate, releasing gas and dust that stream outward, forming tails that stretch millions of kilometers. These tails always point away from the sun, sculpted by the solar wind, like luminous veils trailing behind a silent traveler. From Earth, this display is breathtaking, a streak of light across the sky, delicate, ephemeral, drifting slowly. And yet, the comet itself remains unchanged in its purpose, following its path with quiet inevitability. Beyond their beauty, comets carry history. They are among the oldest objects in the solar system, formed from the same primordial material that once built the planets. Their icy interiors preserve a record of conditions billions of years ago. Some scientists even suggest that comets may have delivered water and organic molecules to the early Earth, seeding the conditions for life. In this sense, they are not only wanderers but givers, carrying gifts across time. And still, they remain humble. Unlike stars or galaxies, they do not blaze eternally. Their appearances are brief, their brightness fading after a few weeks or months before they return to the cold outskirts. Most of their lives are spent in silence, drifting through the Kuiper Belt or the Oort cloud, far from the sun's warmth. There, in the deep, they wait patient, frozen, timeless, until gravity calls them inward again. Philosophically, comets embody the idea of return. They remind us that even across vast distances and long silences, cycles persist. They are wanderers, yet they always come home. Their arcs across the sky reassure us that the cosmos, for all its immensity, contains patterns that repeat, rhythms that endure. To lie beneath the night sky and see a comet is to witness time stretched beyond human measure. It is to know that others before us saw the same glow, centuries or millennia ago, and that others after us will see it again. Comets are not only icy wanderers, they are threads that connect generations, weaving humanity into the slow rhythm of the universe. There are moments when the cosmos paints directly upon the sky of Earth, and among the most tranquil of these are the auroras. Draped like soft curtains of light across the poles, they shimmer in greens, purples, and reds, rippling gently as though stirred by an unseen hand. They are not storms in the violent sense. They are songs, manifestations of Earth's invisible shield, meeting the whisper of the sun's breath. Auroras begin far away. In the restless surface of the Sunday, streams of charged particles are cast outward, drifting across the solar system in what we call the solar wind. When these particles reach Earth, most are deflected by the planet's magnetic field, yet some are guided along magnetic lines toward the poles, where they collide with atoms in the upper atmosphere. In those collisions, oxygen and nitrogen release light. The result? Shimmering waves, dancing veils, the heavens themselves painted in flowing strokes of green and violet. From the ground, the aurora appears alive, in constant yet patient motion. Curtains fold and unfurl, arcs stretch across the horizon, silent coronas flare above, dissolving into ripples of color. And yet, despite their scale and their beauty, they make no sound. The spectacle is wordless, as though nature itself chose to whisper rather than shout. Seen from space, auroras form vast ovals around the poles, glowing halos that show Earth breathing with light. Astronauts aboard the International Space Station watch them drift below like rivers of color flowing across the night side of the planet. Even from orbit, their calmness is unmistakable, an atmospheric lullaby, soft and steady. The colors carry meaning. Oxygen glows green and red, nitrogen deepens the palette with blues and violets. Each shade is the expression of a quiet interaction, a particle meeting an atom releasing light. Billions of such interactions occur in every second of the aurora, yet their combined effect is serenity, a vision that has inspired awe since ancient times. For those who lived under polar skies, the aurora was never mere light. It was spirit, messenger, omen. Cultures across the world saw in it reflections of ancestors, the dance of souls, the fires of unseen realms. Even in myth, the aurora was not chaos but wonder, a quiet reminder that the heavens were alive. Philosophically, the aurora invites reflection on fragility. It is the meeting of earth and sun, of atmosphere and particle, of magnetism and light. Without Earth's magnetic field, the solar wind would strip our air away, leaving the planet bare. But instead, the field bends and softens the impact, transforming what could be destruction into beauty. In this sense, auroras are a metaphor. Even in collision, there can be grace. To stand beneath an aurora is to feel small yet comforted, to know that the universe is vast but also tender, capable of moments that are both powerful and soothing. The aurora is Earth's lullaby, sung in the colors of the sky, a curtain of light that drifts quietly across the night, asking us not to fear the immensity above, but to rest within its glow. Among the countless stars that fill the galaxy, there are planets that orbit in silence, many of them too distant to see directly. Some are rocky, barren, or scorched. Others are shrouded in clouds, or wrapped in atmospheres unlike our own. But there are those still only imagined, yet increasingly hinted at, that may hold oceans, vast and tranquil seas hidden beneath alien skies. These are the exoplanets with oceans, the possible water worlds drifting far beyond our reach. Water is one of the gentlest of substances, and yet it is also one of the most persistent. On Earth, oceans cover more than 2/3 of the surface, shaping climate, nurturing life, reflecting starlight in endless motion. If such oceans exist elsewhere, they would be no less serene, no less patient. Their tides swayed by alien moons, their surfaces rippled by winds that have never touched human skin. To imagine them is to imagine calm worlds, distant and untouched, where waves have rolled for billions of years, unseen by any eyes. Astronomers have begun to detect hints of such worlds. Through the transit method, watching starlight dim as planets pass across their stars, we have discovered thousands of exoplanets, some of them in the habitable zones where liquid water might persist. Kepler 22b, GJ 1214b, and TOI 1452b are among those suspected of harboring vast oceans. Though we cannot yet see their surfaces, their sizes and densities suggest water in abundance, perhaps entire planets covered by global seas. Even moons may host hidden oceans. Europa, beneath its icy crust, is thought to contain more water than all of Earth's oceans combined. Enceladus, with its geysers spraying into space, hides a saltwater sea beneath frozen plains. These oceans, locked away in silence, may stretch endlessly beneath the ice, warmed not by sunlight, but by tidal forces' slow, patient heating over millions of years. If life exists there, it exists in calm darkness, nurtured by the quiet rhythm of subsurface tides. To picture an ocean on an exoplanet is to picture reflection, starlight glimmering on an alien sea, moons casting pale shadows across rolling tides, winds shaping waves beneath skies tinted with unfamiliar colors. These are not places of noise, but of stillness, vast reservoirs of patience and possibility. Even without life, their mere existence would be poetry, liquid water, stable and enduring, waiting quietly across cosmic distances. Philosophically, the idea of exoplanetary oceans is deeply soothing. It suggests that Earth is not alone in its softness, that among the harsh rocks and burning suns, there may be other worlds of calm, where water rests in great silence. It tells us that the universe, so often imagined as cold and hostile, may cradle gentle havens, repeating the serenity of seas in places we will never walk. Even if we never reach them, the knowledge of their possibility is enough. For to know that oceans may ripple beneath alien skies is to know that calmness is not rare, not unique to Earth, but part of the universe's language. Across unimaginable distances, the cosmos may whisper again and again through water, repeating its soft refrain: patience, reflection, stillness. To drift to sleep imagining these oceans is to imagine serenity unbounded, seas beyond stars, tides beyond galaxies, all moving slowly, endlessly, in harmony with the universe's great silence. Not all stars are short-lived infernos that blaze brightly and then vanish. Some burn with extraordinary patience, glowing faintly for timescales so vast they stretch far beyond the lifetime of galaxies themselves. These are the red dwarfs, small, cool stars that smolder rather than flare, living not for billions but for trillions of years. They are the universe's quiet guardians, keeping watch long after brighter suns have faded into silence. Red dwarfs are the most common stars in the cosmos. More than 3/4 of the stars in our galaxy belong to this class, yet none are visible to the naked eye from Earth. They are too faint, too modest, shining only in nearby neighborhoods where telescopes can find them. And yet, in their humility lies endurance. Their fuel burns slowly, their hydrogen consumed at a pace so measured that they may outlast almost every other kind of star. While giants roar briefly and die, red dwarfs endure in quiet glow. Their size is part of their secret. Containing only a fraction of the sun's mass, they are stable against collapse. Their interiors mix constantly, so the hydrogen at their cores is never isolated. Every bit of fuel is eventually consumed, leaving nothing wasted. Where our sun will live 10 billion years before swelling into a red giant and fading, a red dwarf can shine steadily for trillions. No red dwarf has ever yet died. The universe is not old enough for even one to have completed its lifespan. They are still in their youth, glowing faintly, waiting patiently for eons to pass. For planets that orbit them, red dwarfs offer both promise and challenge. Their habitable zones lie close, where warmth is steady, but such proximity can mean tidal locking, one side in perpetual day, the other in endless night. And yet, even here, there is possibility. Twilight worlds circling faint suns, oceans warmed for trillions of years, stability lasting longer than the age of the cosmos itself. Life, if it arises around such stars, would have time beyond imagining to grow, adapt, and endure. Philosophically, red dwarfs are reminders of quiet strength. They do not need brilliance to matter. They do not need spectacle to endure. Their gift is time, vast stretches of it, offered freely to the galaxies, like candles that never extinguish. If humanity were to one day seek refuge among the stars, it may be around a red dwarf that we find our longest home, resting beneath a steady glow that will not fade for countless ages. In the far future, when bright stars have burned out and galaxies grow dim, red dwarfs will still be there, flickering softly in the night. They will be the universe's final embers, the last notes in the great symphony of starlight, holding warmth and light when most of the cosmos has gone dark. To think of them is to find comfort in longevity. They are proof that not all things end swiftly, that some burn slowly, patiently, endlessly. In their faint glow lies the promise of continuity, the assurance that the universe's lullaby does not end quickly but drifts on, soft and unbroken, across trillions of years. All things drift towards stillness. This is the lesson of entropy, the universe's slow surrender to disorder, to evenness, to calm. At first glance, entropy may seem unsettling, a law that predicts the fading of stars, the cooling of galaxies, the eventual quieting of all things. But in truth, it is not chaos that entropy describes, it is rest. It is the gradual dissolution of difference, the evening of contrasts, the cosmos exhaling into stillness. Entropy is the second law of thermodynamics. In any system, disorder increases. Heat flows from hot to cold. Energy spreads until it is evenly shared. Stars, burning brilliantly, radiate warmth outward, and over billions of years, that warmth dissipates into space. Galaxies, once dense with matter, thin and stretch, motion slows. Differences blur. The universe does not collapse into fire, but fades into quiet. This concept has given rise to the idea of the heat death of the universe, a distant epoch when stars have burned out, black holes have evaporated, and all matter has cooled into uniform stillness. At that point, no processes will remain to create order, no energy gradients to drive motion. The cosmos will rest in equilibrium, perfectly balanced, perfectly silent. And yet, when seen from a different perspective, this is not frightening but soothing. Entropy tells us that the universe has direction, that its story is not endless struggle but gentle resolution. Just as a day fades into evening and evening into night, so too does the cosmos move toward rest. The end is not violence but calmness, not fire but hush. Already, entropy is visible around us. Stars release their energy steadily, leaving behind white dwarfs that glow faintly for trillions of years before cooling. Gas spreads thinly across galaxies, no longer condensed into clusters as tightly as before. Even within our own lives, entropy whispers the cooling of tea left untouched, the fading of sound in an empty hall, the slowing of motion when effort ceases. Everywhere, the universe teaches us of balance, of stillness, of rest. Philosophically, entropy is an acceptance of impermanence. It reminds us that nothing remains unchanged, that even the brightest flames must fade. But in that fading, there is serenity. Just as sleep is not loss but renewal, entropy is not destruction but return, a return to calm, to silence, to equilibrium. To imagine the ultimate entropy of the universe is to imagine a great quiet, a lullaby that began with the fire of the Big Bang and will end in stillness. Stars born, galaxies spun, black holes whispered, and at last, all things at rest. It is not a tragic vision but a peaceful one, the final page of a story that was always written to close with calm. Entropy, then, is the universe's promise of rest. It is the assurance that motion and noise are temporary, that all things will one day soften into silence. For those who long for peace, it is perhaps the gentlest law of all. When night falls and the air cools, the sky opens, and with it comes one of humanity's oldest comforts, the eternal night sky. To gaze upward is to encounter a dome of stillness, scattered with stars, each a distant sun, each a reminder of the universe's immensity. The sky is not loud, it does not clamor for attention. It waits, patiently, as it always has, offering calm to anyone willing to lift their eyes. For millennia, people have turned to the night sky not only for navigation, but for solace. The constellations are not just patterns of stars, they are anchors, familiar shapes that persist across generations. Orion's belt, the Pleiades, the curve of the Big Dipper. These forms endure, whispering to every culture the same story of continuity. To the farmer, they brought seasons. To the poet, inspiration. To the wanderer, a sense of direction. To all, they offered perspective, the reminder that while human lives change quickly, the stars remain steady. Astronomically, this constancy is illusion. The stars do move, shifting subtly over millennia, drifting along their galactic orbits. Yet, the pace is so slow, so patient, that for us the constellations appear eternal. The night sky becomes a kind of still painting, each point of light a steady brushstroke on black canvas. That stillness is what makes it so soothing. It gives the impression of permanence in a world where little else feels permanent. And yet, within that quiet, there are surprises. Shooting stars, tiny fragments burning gently in the atmosphere, flash across the dark with fleeting brilliance. Planets wander, their steady paths slightly different from the stars, glowing softly with borrowed sunlight. Even the faint Milky Way, stretching overhead like a river of light, is not noise but harmony. Billions of stars woven into one glowing band, flowing across the heavens. The night sky is more than beauty. It is perspective. Each star we see has been burning for millions or billions of years. The light itself has traveled vast distances, crossing gulfs of emptiness to arrive here, now. When we look at the stars, we are looking into history, into memory preserved in photons, into a universe that has been shining long before us and will continue long after. This awareness is not frightening, it is calming. It tells us that we are part of something vast, enduring, unbroken. Philosophically, the eternal night sky speaks of both smallness and belonging. We are small, yes, but we are not excluded. The same stars that guided ancient travelers still guide us. The same constellations seen by distant ancestors shine above us tonight. The sky belongs to no one and to everyone, equally. Its calm silence is universal, shared by all who pause to look. To close one's eyes after gazing upward is to carry that stillness inward. The eternal night sky, with its endless calm, becomes a reminder not only of cosmic scale but of inner quiet. It is the universe's invitation to rest, to let go of urgency, and to dissolve into the same calm rhythm that carries the stars across the heavens. In the vastness of the cosmos, there is a humbling truth. We are small. Against galaxies that span hundreds of thousands of light years, against clusters that stretch across millions, against the expanding fabric of the universe itself, our world is but a pale dot, and yet, in this smallness, there is calm. Perspective softens fear. To know we are not the center of everything is to be released from the weight of importance, to rest in the knowledge that the cosmos is not burdened by our struggles. Astronomer Carl Sagan once called Earth a pale blue dot, captured in a photograph by Voyager, one from nearly 4 billion miles away. In that image, Earth is less than a pixel, a speck suspended in a sunbeam. To some, this image brought insignificance. To others, it brought comfort, for if our world is so small, then our conflicts, our anxieties, our rushing lives are smaller still. The universe holds them, yes, but it does not revolve around them. We are free to let them go. From a cosmic perspective, even the mightiest events of history are whispers. Empires rise and fall, languages are born and fade, species emerge and vanish, all in the blink of an astronomical eye. A star may burn steadily through 10 billion years, indifferent to the passing of civilizations on a small planet orbiting quietly around it. Galaxies drift in their slow arcs, while human generations hurry through brief lifetimes. To see this is not to despair, it is to breathe, to know that the weight of urgency is an illusion born of scale. And yet, though we are small, we are not excluded. We are made of stardust, built from atoms forged in ancient stars that died long before Earth was born. Our blood carries iron from those explosions, our bones carry calcium from stellar forges, our very breath relies on oxygen shaped in stellar hearts. To be small is not to be insignificant, it is to be part of something vast, to carry within ourselves the memory of the universe. Philosophically, this perspective offers serenity. It reminds us that we are not masters of the cosmos, nor are we separate from it. We are participants in its story, threads in its fabric, temporary patterns in its great unfolding. Our smallness is not loneliness, but belonging. Just as a single drop belongs to the ocean, so do we belong to the cosmos. To look up at the night sky and feel small is to feel aligned with truth. It is to release the burden of control and allow oneself to rest within the vast whole. Our joys, our griefs, our ambitions, they matter to us, but they do not disturb the stars. They do not halt galaxies. They are safe to soften, to let dissolve into the calm backdrop of eternity. Smallness, then, is not weakness. It is a form of freedom. The cosmos invites us to step back, to see scale, to breathe easier, knowing that we are part of something immense, steady, eternal. And in that perspective lies comfort, the calmness of knowing that while we are brief, we are also infinite, carried always within the embrace of the universe itself. At the edge of all speculation lies the final hush, the destiny of the universe, when all motion slows, when all light fades, when silence reigns supreme. Cosmologists call it the heat death, or the quiet dissolution into equilibrium. Stars will have burned their last fuel, black holes will have radiated themselves away into nothing. Galaxies will drift apart until their light can no longer reach one another. What remains will be darkness, an ocean of thin particles and faint radiation stretched across infinite space. It is not an ending of violence, but of stillness. No great collapse, no final explosion. Instead, it is the softest of closures, the universe exhaling and settling into rest. If one could witness it, one would see not chaos but tranquility. A cosmos without contrast, without tension, at peace in its uniformity. Time itself would continue, but with nothing left to change, it would become indistinguishable from eternity. Some find this prospect unsettling. To imagine all beauty fading, all stars extinguished, all galaxies gone, can seem like loss, yet there is also serenity in it. For the universe's story is not cut short, not ended abruptly. It drifts slowly toward quiet, as a river broadens into a calm sea. Every process, every motion, every light has its time, and then it yields, softly, to silence. Philosophically, this hush is not despair, but reassurance. It tells us that all things find rest, that the cosmos itself, after its long journey of creation, growth, and transformation, will settle into peace. And in that final peace lies symmetry, the same calmness that marked its beginning when space first expanded in silence will mark its end. The universe will return to quiet as though completing a breath. For humanity, the thought of this distant fate need not bring fear. It lies so far ahead that even stars unimagined will have risen and faded before it comes. Instead, it offers perspective. Our lives, brief though they are, unfold within a universe that began in silence and will end in silence. To exist at all between those two hushes is a miracle, a chance to be part of the song before it fades. And so the cosmos will close its eyes, not with thunder, but with calm. The final hush will be the gentlest sound of all, the silence of everything at rest. And now, as the journey of thought comes to its close, let the rhythm of the universe soften into a whisper. The stars, once bright in our imagination, begin to dim. Their light lingers, fading gently across time, like embers that refuse to die suddenly but instead glow faintly as they drift into darkness. The galaxies, so immense and graceful, slide away into the distance, their motion slowing in the mind until they are but memories upon an infinite canvas. The silence of space grows deeper. Where once there were voices of light, there is now calm. Where once the cosmos sang in fusion and fire, there is now stillness. This stillness is not empty, it is comforting, like a blanket drawn over the restless. It is the final exhalation of the universe, a sigh carried through eternity. Breathe with it now. Imagine yourself floating in that great quiet, supported by nothing and everything. No need to move, no need to think, no need to hold on to time. The river carries you gently, its current unhurried, its surface smooth. There is no urgency, no demand, only calmness. Every photon that touched your eyes tonight, every thought carried through this story, was the gift of the universe itself, reaching across light years to soothe, to remind you of your place within it. You are small, yes, but never alone. You belong to the same fabric, the same web, the same story. And that story is vast enough to cradle all that you are, all that you dream, all that you let go. Now, let the stars dim, let the galaxies fade, let the hush of the cosmos surround you. Sleep within its silence, rest within its eternity. The universe is at peace, and so are you. Sweet dreams.